Hello students, last time I had explained you how to find out the square root by division method, and on that day I told you in between some different concepts are there that I am going to send you on the screen recorder video. But I could not send it promptly. Now I am sending those videos. It is based on your textbook only. Now, next point which I had not explained, that is adding odd numbers. Now all of you know odd number means 1, 3, 5, 7, 9, like this. So if we consider here one odd number 1, square of 1, 1 square 1. Then next odd number is 3, 1 plus 3, that is equal to 4. See here, 1 plus 3 is equal to 4. That is, now 4 is nothing but 2 square. See, first only one odd number, that 1 square 1. Then afterwards 1 and 3. 1 plus 3 4. That is also square of 2 square. Now 1 plus 3 plus 5. That is 3 square. Then 1 plus 3 plus 5 plus 7. So if you see here, how many numbers are there? Suppose 4 numbers are there, it is a square of 4. If 5 numbers are there, it is a square of 5. So here you can conclude that the sum of first n odd natural numbers is n square. First n means how many odd numbers will be there? That's the sum of those numbers will be that number square. Are you getting that? Means here you can consider sum of successive odd numbers starting from 1. Okay, means if the number is a square number, if that number is a square number, it has to be the sum of successive odd numbers starting from 1. Means you should consider from 1, not in between. Okay, so this one more rule we have got. Now if we consider the another numbers, means which are not a perfect squares, 2, 3, 5, 6. So can you express these numbers as the sum of successive odd natural numbers beginning from 1? Let us check here. You will find that these numbers cannot be expressed in this form if it is not a square. So consider that number 25. Now 25 is a square number. So what we will do? We will start to subtract all consecutive odd numbers starting from 1. 25 minus 1, 24. 24 minus 3, 21. Means after 1, 3 came. After 3, 5. So we have to subtract. Means from this answer, you have to subtract next odd number. Okay. So here 16 minus 7, 9. So if we will continue till 0. If 0 came, means it is a square. Okay. This means that 25 is nothing but the sum of consecutive first 5 odd numbers. See, 1, 2, 3, 4, 5. 1 plus 3 plus 5 plus 7 plus 9. They are consecutive odd number. Are you getting this? Means if it is a square, perfect square, it will be a sum of first n consecutive odd numbers. Now let us check any other number. Suppose 38 if we consider. What? 38. So as per the procedure, we will start from the first odd number. 38 minus 1, 37. 37 minus 3, 34. 34 minus 35, 29. Then 29 minus 7. So till last if we go, that we will get the number which is less than 0. So 2 minus 13 minus 11. This shows that we are not able to express 38 as the sum of consecutive odd numbers starting from with 1. So also 38 is not a perfect square. So what will the conclusion? So conclusion will be that if a natural number cannot be expressed as a sum of successive odd natural numbers starting with 1, then it is not a perfect square. If we are unable to express any natural number in the form of sum of successive odd natural numbers, then it is not a perfect square. That's all. So based on that, here they have given some sums. See here. find whether each of the following numbers is a perfect square or not. So you can use this procedure. Okay, let us see now next point. Now here also next point is what? Product of two consecutive even or odd natural numbers. Okay, which number we have to consider? Consecutive even or odd. For example, if I will take 42, then 42 into 44. If I will take 2, 2 into 4, 8, like this. So here they have considered odd numbers, 11 into 13. Okay, so it is 143. So how we have to do this product without multiplication by another way? So what they did, 11 means what? 11 and 13 means in between number 12. So 12 minus 1, 12 plus 1. Okay, so 12 minus 1 into 12 plus 1. So you can apply the formula a plus b, a minus b. Which formula here you can apply? A plus b in another bracket a minus b is equal to a square minus b square. Okay, like this you can apply. Once again I am writing a square minus b square, like this. Okay, so you will get this. So for example, 39 plus 31, middle number is what? 30. So 30 minus 1, 29, and 30 plus 1. So instead of doing multiplication, you can get the answer 30 square 900 minus 1, whatever the answer. So in general we can say that a plus 1 into a minus 1 is equal to a square minus 1. So this one more pattern we have got here. Now see here. So based on that exercise, last time I told you, you have to study some pattern and solve like that. Okay. Now one more pattern here we'll learn. This was the exercise. Finding the square of a number. Suppose you want to find out any square of small numbers like 3, 4, 5, 6, 7. Easy to find. But if you want to find square of more than 20, more than 25, like this, so how to find out? For example, now 23 square. So 23 by 23 multiplication, somewhat some students will feel difficult. So what you can do? You can arrange that number 23 as a sum of two numbers, that is 20 plus 3. But one number should be a round figure like 20, 10, 100, like this. So then you have to do 20 plus 3 bracket square. Now 20 plus 3 bracket square means you can write 20 plus 3, another bracket 20 plus 3. So otherwise, if you know the expansion of a plus b bracket square is equal to a square plus twice ab plus b square. So what they did here, 20 plus 3 bracket square, that is 20 into 20 plus 3 plus 3 into 20 plus 3. So 20 square plus 20 into 3 plus 3 into 20 plus 3 square. So 400 plus 60 plus 60 plus 9, that is equal to 529. So like this also you can solve. Otherwise you can apply the formula which I told you, a plus b bracket square, that is a square plus b square, twice ab plus b square. So here I will write here a plus b bracket square is equal to a square plus twice ab plus b square, like this. You will get, means instead of doing multiplication you can do this. For example, suppose 54 square, so you can write 50 plus 4 bracket square. Here 50 square plus 2 into 50 into 4 plus 4 square. Like this you can do. So like that, here they have given the examples here. 39 square means 39, 30 plus 9 bracket square. So 30 plus 9, 30 plus 9 multiplication they have done. So 42 square, same way. Let us see more patterns, other patterns. Now you can see at 25 square. 25 square, this already I told you. I have given the heading, how to find out the squares of such numbers which are having 5 at their unit place, and one more method, which are having 1 at their unit place. That already I have taught you in last lecture. Now next important point is Pythagorean triplet. All of you have studied Pythagoras theorem. That in Pythagoras theorem you can you know that we need right angle triangle. So right angle triangle is having what? Hypotenuse, and remaining two sides they are making what? Right angle, like this. So hypotenuse square is equal to one side square plus other side square. Okay. So here also there are some particular numbers in such a way that the sum of squares of two small numbers is equal to the square of the greatest number. For example, 3 square plus 4 square is equal to 9 plus 16, and which is 9 plus 16, which is equal to 25, and 25 is the square of 5. So 3, 4, 5. So 3 square plus 4 square is equal to 5 square. Means sum of the squares of smaller two numbers is equal to square of their greater number. So those three numbers are called Pythagorean triplet. They are called Pythagorean triplet. Similarly, 6, 8, 10. You can check 6 square 36, 8 square 64. So 36 plus 64, 100, and 100 is nothing but the square of 10. So 6, 8, 10, they are also having Pythagorean triplet. So one more triplet they have given here. See, 25, 144 and 1 means 5, 12 and 13, because 25 is the square of 5, 144 is the square of 12, and 169 is the square of 13. So this is also Pythagorean triplet. Okay. Now next pattern we'll see. But can we check whether the given triplet or given numbers is Pythagorean triplet? So see, one method is given here. Any natural number you have to consider. What? Any natural number you have to consider, but that natural number should be greater than 1. So we have such numbers. If m is greater than 1, then 2m square plus m square minus 1 bracket square is equal to m square plus 1 bracket square. So here you are getting such numbers which are in the form of 2m, then m square minus 1 and m square plus 1, the Pythagorean triplet format. Okay. So based on that you can solve the sums here. Write the Pythagorean triplet whose smallest member is 8. So you can consider, suppose 2m is equal to 8, find out the value of m. Otherwise m square minus 1 is equal to 8, anything. So let us check here. First they have considered, we can get the Pythagorean triplet by using general form 2m m square minus 1 m square plus 1. So first they have considered m square minus 1 is equal to 8, because what they have given? Smallest member. What they have given here? Smallest member is 8. So that should be a smallest number. So m square minus 1 is equal to 8. So 1 will shift there. It will become plus. M square is equal to 8 plus 1 is equal to 9. So m is equal to 3. Then 2m is equal to 6. So and m square means 2m is equal to 6. How? 2 into 3 is equal to 6, and 3 square 9 plus 1 10. So we are getting 8, 9, 10. Which number? Sorry, 6, 8, 10. But here 8 is not the smallest number, it is middle. So our assumption considering m square minus 1 is equal to 8, that is wrong. So another we can consider here. See, we will consider 2m is equal to 8. Therefore m is equal to what? 4. M is equal to 4. Then m square minus 1 means 4 square 16 minus 1 15, and 4 square 16 plus 1 17. Here 4 is coming smallest number. So here 8, 15 and 17 with 8 as the smallest number. So it is correct. Then one more sum like this: find a Pythagorean triplet in which one member is 12. So again any out of those three, m square minus 1, m square plus 1 and 2m. So if we'll consider m square minus 1 is equal to 12, m square is equal to 12 plus 1, 13 will come. So square root of 13 will be not an integer. So then the value of m not integer. So we try another. M square plus 1 is equal to 12. Again m square is equal to 11. See here. M square is equal to 11. So square root of 11 is not present. If we consider 2m is equal to 12. So m is equal to 6. So m square minus 1. 6 square minus 1, 35 and 37. So 12, 35, 37. Okay. So that will be the triplet. Now remember that all Pythagorean triplets, by this method you will not get all the Pythagorean. This is important. All Pythagorean triplets may not be obtained using this form. For example, another triplet 5, 12, 13 also has a 12 as a member. Okay. So considering this only rule, it is applicable for some particular numbers only. Then next point is square roots. Now I told you that what if 4 square is equal to 16, then it means square root of 16 is equal to 4. Okay. So here we will study regarding square and square root. So here they have given one small example. They have shown here square. ABCD is a square in which AC is the hypotenuse. So what is the length of the diagonal? Now in case of quadrilateral it is called diagonal. In case of only single triangle ABC or ADC it is called hypotenuse. So what is the length of diagonal of a square of 8 centimeter? Can we use Pythagoras theorem? Yes, you know Pythagoras theorem, just I had told you AB square plus BC square is equal to AC square. So 8 square plus 8 square is equal to AC square. 64 plus 64 AC square. AC square is equal to 128. What is the question? Can we use what is the length of diagonal? So diagonal length is 128, but square root should be there, no? So here again, to get AC we need to think about the number whose square is 128, means we have to find out square root of 128. Okay. So here in a right angle triangle, the length, one more example they are given, hypotenuse and the side are respectively 5 and 3. Can you find the third side? So hypotenuse is given 5 centimeter. The next side is given 3. The remaining side you can consider as x. So let x centimeter be the length of third side. So applying Pythagoras theorem, 5 square is equal to x square plus 3 square, 25 is equal to x square plus 9, 25 minus 9 is equal to x square, 16 is equal to x square. Again to find x, we need a number whose square is 16. Okay. Now finding a square root, 1 square 1. So square root of 1 is 1, 2 square 4, therefore square root of 4 is 2. That I already told you. 3 square is equal to 9, square root of 9 is 3. See here, 9 square 89, and also negative 9 square is also 81. Sorry, 9 square 89, not 81. And negative 9 bracket square is also 81. So we can say that square roots of 81 are 9 and minus 9. Okay. So 11 square is equal to 121. So square root of 121 is 11. 14 square is equal to 196. Square root of 196 is 14. Then minus negative 1 square is 1. So negative 1 is the square root of 1. Negative 2 square is equal to 4. So negative 2 is the square root of 4. So like that it is, you can write. But here you may say that there are two integral square roots of perfect square number. In this chapter we shall take up only positive square. It is there, but we are considering only positive square root. Remember that this is important. In this chapter we will only consider positive square root, means square root of 9 we will accept 3 only, not negative 3. Similarly here, if we consider square root of 4, we will accept only 2, not negative 2, for our convenience. Okay, so here we will see here 1 square 1, it's in inference, square root of 1 1, 2 square 4, square root of 4 is 2, like this. If we'll go on, 10 square 100, square root of 100 is 10. How to read? Square root of 81 is equal to 9, square root of 64 is equal to 8, square root of 49 is equal to 7, square root of 36 is equal to 6. Now finding the square root through repeated subtraction. So last time we had seen, no. So suppose 81 is square root, so as I told you, you should start subtract from 1, 81 minus 1, 80 minus 3, like this. Where we have stopped here, this, from 81 we have subtracted successive odd number starting from 1 and obtained 0 at the 9th step. See here, how many steps are here? 9. So square root of 81 is 9. So same way you can see. So by repeated subtraction of odd numbers starting from 1, from whether the following numbers are perfect squares or not. If the number is a perfect square, then find its square root. So you can solve that. Okay. So here finding square root by prime factorization. So this method we will discuss afterwards. Up to here I think this is enough. Okay. Thank you.